Hi everyone. Today let's look at the LeetCode problem 703, kth largest element in a stream. You are part of a university admissions office and need to keep track of the kth highest test score from applicants in real time. So basically we have to find the kth largest element. So the moment k comes in, most of the time heap is one possible candidate. Okay, let's dive a little bit deeper here. This helps to determine cutoff marks for interviews and admissions dynamically as new applicants submit their scores. You are tasked to implement a class which, for a given integer k, maintains a stream of test scores and continuously returns the kth highest test score after a new score has been submitted. We are given a class, okay? We have to maintain. So at first we are given a number of scores, okay? And we are given a number k here. And at any point, whenever they try to add a new score, we have to always return the kth largest element. Now, let's look at an example for better understanding. I'm just skipping this part. Feel free to read this question further. Okay. So now take this case. Let's think from a brute force approach. Okay. Now if I am given 4, 5, 8, 2 and k is equal to 3, then if I just sort this, then iterate from the back, okay, then the third largest would be, for example, this will become 2, 4, 5, 8. So the third largest will be 4 from the back. And so if, as you can see, that will be an n log n operation. And now when I insert 3, again I have to sort it and then take the third largest element. So each add operation, so to start with, at first itself we'll have to sort it, so that will be an n log n operation. Then each add operation will also be an n log n operation because we have to sort it each time. Can we do better? So that's where our initial approach of a heap will be useful. Now let's jump into a use case and see how we can solve this. Okay, I will, let me keep it this big, then we'll go down. Okay, now this is our, as you can see, this is our initial input. Okay, and we are given that k is equal to 3. Okay, these are our remaining add operations. Okay, we will keep it aside to start with. Now let's use a heap here. Okay, and I'll tell you why a min heap. Okay, now given this many values, assume that we just push all these things into a min heap. So what will happen is 4, 5 and 8. Okay, now if you see here k, so now what will be your if I have a min heap of size 3, or I'll just generally make it as k, then the min heap will always give me the kth largest element. I believe this is clear. So now if you see here 4, 5, 8 and I want the third largest element, then the min heap top will be the kth largest element. Now imagine that I bring in 2. Now the size is k plus 1. So what will happen is it is this way. And as you can see, there is no point in having 2 because any value less than the top of the heap doesn't make any sense. Or we can even generalize this. At any time, ensure that we always have only k elements in our min heap. Then it is guaranteed that the top of the min heap will always give me the kth largest element. Now let's take a little bit example further. Okay, so in the first kth largest function, assume that we maintain only k elements. Okay, and then what we do is next 3 comes in. Okay, one way to do this is just insert it. Okay, and always ensure that the heap only contains 3 elements. Then this will end up as this way, and this add function can actually return 4. We will return 4. So that means you will still get the kth largest element as 4. Now comes 5. Okay, so what will happen is this will become 4, 5, 5, 8, and we take out the kth element. So this means, we'll just reduce its size back to k. So that means at the top of the min heap will still give me 5. Will give me 5. Here it will give me 4. And now next time when we insert 10, this will become 5, 5, 5, 8, 10. And again we will just we will pop until we become where the min heap size becomes 3. And as a result we will get again 5. And now we will insert 9. This will become 5, 8, 9, 10. Now we will ensure that the heap size is brought back to k, that is, so this will become again, this will give 8, and this will continue. So if you see this, with this approach, our initial insertion will be maybe like we can actually maintain this as n log k, okay, or a worst case of n log n, okay, and here what we can do is I would keep it as n log k because I can ensure that the heap size doesn't grow beyond k. Then what we can do is here we can make this as we can do one thing. We can actually have this as n, order of n, and then what we can do is first we'll insert everything and form it. Then what we can do is we can take out n minus k log n elements. Okay, this is another way, but I think the critical piece will be this add function. That is where we will gain a lot of time. So here if you see, all these operations will be log k. Okay, so a log k to insert and a log k to pop. Okay, this, I believe this is clear. Now let's code this up. Okay, to start with, let's create a min heap. I'll just create a private variable called priority queue. So this will be int, and this will be vector int. It's a min heap, so vector int. Okay, we'll just reduce the size a little bit. Okay, so that, okay, I believe it's visible. So then min heap. Okay, now what we can do is I'll keep it very simple. For auto and n nums, what we can do is we can just nums dot push, min heap dot push n. I think I'll also have to keep k, so I'll just keep this as int nk. So I'll just keep nk is equal to k. Okay, then what can I do? So this will go on if min heap dot size greater than k, min heap dot pop. So I'll always maintain this min heap at size k, because any element less than that doesn't have any value addition, so we'll keep it that way. Then now let's go to the addition of the elements. Okay, so let's take this case. So we have pushed it here. We will just push this element. So min heap dot push val if min heap dot size greater than nk, then min heap dot pop. I don't think we'll need a while loop here because we will be inserting one by one. Min heap dot top. Okay. Yeah, I could make it slightly better. I could add a condition to check whether it is smaller than the min heap dot top and then decide whether to insert or not. But this will be very simple. So this will be a if you see here, this operation will be log k, and this operation will be this operation will be log k. Okay, now let's just run this. This looks good. Okay, this looks good. Okay, thanks. Have a good one.